Okay, today we're going to keep talking about proportionality, and we are going to use our scale factors that are going to be fractional scale factors, so we're going to talk about how to do that. So, if we look at this problem, Jody used a photocopier to reduce a rectangular image that was 5 inches wide and 7 inches long. If the reduced image was 4 inches long, how wide is the picture? So we're going to set up our proportion. We're going to talk about the two ways to set up the proportion briefly again like we did on the last video. It was 5 inches wide and 7 inches long. So one way we can compare these and set up our proportions is the inches wide and the inches long. 5 inches wide, so that would go on top, would be equal to 7 inches long. That's how wide over long. 5 was wide, 7 was long. So when we set that equal to something, we look, well, 4 inches was long. So where does it go, top or bottom? We know long was bottom here, so 4 goes on the bottom. We're looking for how wide. That's what we want to know, so that's where our variable goes. So notice that this is the original picture, and this is the reduced image. This is the image. So we did wide over long, and we did original together and image together. Another way we could set up this same proportion is instead of comparing wide to long, we could go ahead and compare original over image. So if we were doing original over image, then instead of having these labels here, we would say, well, this is the original over image for the width. So all we're looking for is information about the width. So I go up here and I see 5 inches wide. That was the original image. So original image was 5 inches wide. The reduced image then was how wide. That's what we're looking for, so that's where our X is going to go. So the image, the width is what we're looking for in the image. And then we set that equal to the length. 7 inches long, is that the original or the image? That's the original. So 7 goes on top. The reduced image was 4 inches long, so 4 is what would go on bottom. So, if you look at these, I want y'all to see what was the same and what was different about them. Notice that 5 and 4 are always across from each other. 5 always matches 7, 5 matches 7, and 5 matches X, 5 matches X. So if the choice for the way that you set it up isn't an answer choice on your test or anything, you know that you can do it this other way too. Just make sure that 5 and 4 were always across from each other. So make sure the numbers that you had across from each other stay across from each other. So let's go ahead and solve this. So how do we get from 7 to 4? I don't know. From 5 to 7? I don't know. So this is when we go and we think about that scale factor that we used that was a fractional scale factor. So we said when we can't figure out how to get from 7 to 4 and we can't reduce 5/7, we have to do the image over the original. So we're going to multiply 7 times 4 was our image, 7. That's our scale factor then. 4/7 is going to be what we use as our scale factor for this problem. So 7 times 4/7 would get us, put this over 1, 28 over 7, which is 4. So we know that we did it right. So to get from 5 to X, we would do 5 times what scale factor we used, 4/7. Put that over 1. 5 times 4 is 20 over 7. 20 divided by 7 doesn't simplify to a whole number, but we know that when we divide that, 7 times 2 is 14, and we'd have 6/7 left over. So X would be equal to 2 and 6/7. Over here, we could have done the same thing. Our scale factor would have been 7/5. We can multiply by that to get the same thing. So we can do the same thing here.